Okay, this is for section 2.1, and the title is Relations and Functions. And hopefully most of this will be some review from your ALG2. Okay, relations and functions. First, the author defines a relation. A relation is any set of ordered pairs. Any set of ordered pairs. So as an example, and use the set notation, and if I have the ordered pair and say 5, 7, and remember it's always x then y. Another ordered pair, I'm just making these up, 0, -1. Another ordered pair, 2, 4. And it's a set, so you have to have the braces. Okay? These are critical because it does represent a set of ordered pairs. Okay? Then probably the most important definition in upper level math is a function. A function is a special relation. So that means it's a special set of ordered pairs. A function is a special relation such that, and down the road, yeah, a special relation, special set of ordered pairs such that, and down the road in upper level math, the backwards epsilon symbol stands for such that. Higher you go in math, the more symbols you'll get. So a function is a special relation such that for every x value, it is paired or mapped to one and only one y value. So a function is a special relation, special set of ordered pairs such that for every x value it's mapped or paired or mapped to one and only one y value. Okay, so an example I'll give you. You can do it by table, you can do it by a set of ordered pairs, but let's look at a couple of examples. Let's say I did -1, 5, 2, 7, 3, 9. For every x, is it mapped to just one y? Is -1 mapped to just one number? Yes. 2 is mapped to just one number? Yes. So this one is yes, it is a function. Let's do another one. Say I do 2, 5, 3, 4, 8, -1. For every x, is it mapped to just one y? Yes. Say I do 2, 5, 3, 4, 2, 9. Is 2 mapped to just one number? No. For it to be a function, every x value has to be mapped to one and only one. So this one is not a function. And the not part comes from 2. Yeah. And you may want to highlight that or circle it. This throws it off. 2 is mapped to 5. It's also mapped to 9. Okay? Okay, last example on that part. Let's say you do 2, 5, 3, 4, and 6, 5. Yeah. 2 is mapped to just 5, right? That's the only thing that 2 is mapped to. Yeah. 3 is mapped to just 4. 6 is mapped to just 5. Yes, this is a function. So, the case, you cannot have an x repeating, basically. Can you have a y repeating?
Yes.
Yes. Okay? And what you learned in your ALG2 was the vertical line test. Okay? So, on the vertical line test, if you graph any of those, if you graphed any of those tables on the vertical line test, if any 2 points line up and down, basically vertically, if any 2 points line up and down, then it is not a function. So you ought to be able to tell by looking at a graph whether or not it's a function. If 2 points line up and down, it is not a function. This case would be 2 points. You'd have 2, 5 and 2, 9 that would line up vertically. So it's not a function. Okay. Then the author also talks about two special sets, the domain and the range. The domain is the set, and as soon as you see that word, that tells you got to use the braces. The domain is the set of all x values. Okay, and if you write it, usually you use D for domain. And if I'm going to use the example up above. So if I look at this example, the domain, the x values are the 5, the 0, and the 2. The first values in each one of those, 5, 0, and 2. So you have to put it in a set, 5, 0, and 2. And if they repeat, you don't have to write them twice. It's okay if you do, but you don't have to write them twice. Now, some authors will just write it like that. But sometimes on the ACT test or something like that, you might see it written this way. The domain is, look up here for a minute, the domain is the set of all x's such that x equals 5, 0, 2. That says the same thing. I'm okay with either one. The top one's easier, but sometimes they use, and this is called set builder notation, and some authors use that, so don't let that scare you off. You just read it, the domain equals the set of all x's, and you read that vertical line such that x equals 5, 0, and 2. Then another one is the range. The range is the set of all y values in whatever problem you're working. So in my example up above, the y values are the 7, the -1, and the 4. 7, -1, 4. And they'll use range, and it's 7, -1, 4. No. They just have to be in there. Okay. Okay. The next thing the author talks about is the simplifying, and they will give you, let's say as an example, say you're given, and in function notation, let's say you're given the function f of x equals x cubed minus 3. As soon as I tell you that's a function, you know graphically no 2 points line up and down. They can use any letters. Most of the time they'll use f of x. Let's say I give you g of x, and if I write it like that, it's also a function. G of x equals x plus 2. Okay, and they will ask you, say, to find f of -4. Don't make that hard. That just means everywhere you see an x, you're going to substitute in a -4. So if I'm given f of x equals x cubed minus 3, I'm going to substitute in a -4 everywhere I see an x. So I'd have -4 cubed minus 3. So -4 cubed would be -4 times -4 would be 16 times -4, -64 minus 3, right? Check my arithmetic, and I get -67. Okay. Now, when you work a problem like that, you've got to understand that that is just another way to write an ordered pair. The answer would be -67, but when you look at this, this is an ordered pair. It's f of x. So the x is -4, the y is negative 67. Okay, so that's another way to write an ordered pair. Let's try another one. If they said find G of 5, and you'll have to do something like this on the homework. Okay, find G of 5. So that just says in this function, everywhere you see an x, okay, you're going to find sub in 5. So G of 5 is 7. So your answer would be 7. But that is an ordered pair. If they said what was the ordered pair? The ordered pair, the x is the 5, the 7 is the y. Okay? Did you do those in Algebra 1? Functions? Okay. 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 Are we okay with that? Anybody need another example, or are we good? Just everywhere you see an x, you substitute in. Okay, then let's look at the domain and range. Say they ask you to find the domain and the range. And we're going to do these graphically. So, say I give you the domain and range, and I give you a curve like this. Okay? Okay, when you look at that, you go left to right for the domain. Okay, for the domain, you look, and if you extended this graph on up, it's just going to keep going. Okay, so go left to right. As I'm going left to right, am I leaving out any x values of that graph?
No.
No. So the domain is, and it's a set, and we're just going to use a double bar R for all real numbers. For the range, look up here for a minute. For the range, you go from the bottom. You always start at the bottom. What's the first y value in this graph? It is actually 0, right? First y value is 0. And what y values am I using? Greater than or equal to 0, right? It's equal to 0, so for the range, I just write it y is greater than or equal to 0. Okay? Okay, let's try another one. Okay, on this one, I want you to put an open circle. Okay, and this is 1 and this is 2. Okay, and just sketch the line. Okay, now, if you extend these lines on out, okay, go left to right. Am I leaving out any x values? Where's the open circle? What x value? 1. It's an open circle. X is everything else, right? So x cannot equal 1. Okay? It's an open circle. Let x equal 1. So that means it's not included in the graph. Every other x value, if you extended that line on out, every other x value is used. Okay, go from the bottom up from the range. What y value am I leaving out? 2. Y can't be 2. For the range, y cannot equal 2. Can equal everything else. Let's do one more. Okay, for the domain, go left to right. What's my first x value? 0. First x value, so x is it equal to 0? It's greater than or equal to 0, right? The x values in this picture are greater than or equal to 0. For the range, go from the bottom up. Am I leaving out, if I extend this graph on down, am I leaving out any y values? No. So for the range, it's a double bar R. It's all real numbers. So you ought to be able to look at a graph and say, what's the domain, what's the range. When you do the domain, you're going left to right. When you do the range, you're going from the bottom up. Okay? And I think that's it. Okay? Okay, there should be an assignment on the